projected 50% reduction in space travel costs by 2027, transformative effects on aerospace, telecommunications, and defense industries. Overview. As we look ahead to 2027, the aerospace, telecommunications, and defense industries are on the brink of transformative change driven by a projected 50% reduction in space travel costs. This monumental shift is anticipated to stem from advancements in technology, increased investment in space exploration, and rising global competition spurred by nations like China and India. The implications of these changes will be far-reaching, affecting not just space travel but also the broader landscape of air travel, telecommunications, and national defense. Technological advancements fueling cost reductions. A significant factor contributing to the expected reduction in space travel costs is the rapid advancement of reusable rocket technology. Companies like SpaceX are at the forefront, having successfully reduced the cost of space missions to between $60 million and $90 million. A stark contrast to NASA's historical costs of around $2 billion per mission. This innovation alone is projected to lower the costs of launching payloads into space, making it more accessible for both commercial and government entities. The global space economy is expected to experience substantial growth, increasing from $630 billion in 2023 to approximately $1.8 trillion by 2035. This growth is anticipated to be driven by innovations in satellite technology, commercial space travel, and a burgeoning demand for space-based services. The role of artificial intelligence and advanced manufacturing. In addition to reusable rockets, the integration of artificial intelligence, AI, machine learning, and additive manufacturing, 3D printing, is set to revolutionize the aerospace sector. AI and machine learning are enhancing aircraft design and operational efficiency, enabling the development of lighter, more fuel-efficient aircraft. The use of advanced materials such as carbon fiber is projected to improve fuel efficiency significantly. The demand for new aircraft is escalating, with Boeing and Airbus projecting a need for approximately 44,000 new airplanes from 2024 to 2043. This surge is driven by a forecasted increase in global passenger traffic expected to surpass 10 billion by 2025. Consequently, the aerospace sector is embracing sustainability, with companies investing heavily in green technologies such as hydrogen-powered aircraft and sustainable aviation fuel (SAF). Industry challenges and workforce dynamics. Despite the optimistic outlook, the aerospace sector faces several challenges, particularly regarding workforce shortages and supply chain vulnerabilities. The ongoing need for skilled labor in the face of geopolitical tensions affecting material costs is a pressing concern. Reports indicate a significant backlog in aircraft production, with delivery timelines stretching into the 2030s and beyond. This scenario compels airlines to extend the lifespan of their existing fleets, thereby increasing demand for maintenance, repair, and overhaul MRO services. Economic impact and global competition. The anticipated reduction in space travel costs and the resulting growth in the aerospace sector are poised to have a profound economic impact. The commercial aviation sector is projected to generate $1 trillion in revenue by 2025, with the Asia-Pacific region leading the charge in new capacity additions. This economic boom will create opportunities not just in aerospace but also in telecommunications and defense, as advancements in space technology fuel innovations across various industries. The competitive landscape is intensifying, particularly as countries like China and India ramp up their investments in space exploration. The U.S. is responding by prioritizing funding for initiatives like the Space Force, which emphasizes the importance of maintaining a competitive edge in space capabilities. Sustainability initiatives in aviation. Sustainability is becoming a focal point in the aerospace industry. With significant efforts to reduce carbon footprints and comply with stringent regulatory standards. Innovations in hydrogen fuel cells and SAF are critical to achieving these goals. The push for environmentally friendly aviation solutions is not merely a trend, it is essential for the industry's long-term viability in the face of mounting environmental concerns. Emerging trends and future projections. Looking ahead, several trends are expected to shape the aerospace landscape. 1. Space tourism. Companies like Virgin Galactic and Blue Origin are pioneering commercial space travel, making it increasingly accessible to the public. This trend is expected to grow exponentially as competition drives down costs. 2. Autonomous flight. The development of AI-driven autonomous aircraft is on the horizon, promising to revolutionize air travel and logistics. 3. Global expansion of aerospace markets. As emerging markets in Asia and the Middle East continue to grow, the demand for aerospace technology and services is expected to expand, creating new business opportunities. 4. Hybrid and electric aircraft. The transition to hybrid electric aircraft represents a significant step toward reducing aviation's environmental impact, with companies investing in alternative propulsion technologies. 5. Cybersecurity concerns. As the aerospace industry becomes more digitized, the need for robust cybersecurity measures will become increasingly critical to protect sensitive data and ensure operational safety. Conclusion. The aerospace, telecommunications, and defense industries are on the cusp of a transformative era marked by unprecedented advancements in technology and a significant reduction in costs associated with space travel. By 2027, the projected 50% reduction in space travel costs is expected to reshape the landscape of aerospace, making space more accessible and driving innovation across various sectors. While challenges remain, particularly in workforce dynamics and supply chain resilience, the industry's commitment to sustainability and technological advancement positions it for a promising future. As investments in space and related technologies continue to grow, the aerospace sector stands poised to play a pivotal role in the global economy and the exploration of new frontiers. The projected 50% reduction in space travel costs by 2027 is expected to have transformative effects across various sectors, particularly aerospace, telecommunications, and defense. This reduction is primarily attributed to technological innovations, increased investments, and heightened global competition, notably from countries like China and India. Counterintuitive information. 1. Competitive pressure leading to cost reduction. While it is commonly believed that competitive pressure leads to increased costs due to the need for better technology and capabilities, the current scenario suggests that competition, especially from private sector players like SpaceX, is driving costs down significantly. For example, the cost of launching payloads has dropped from NASA's average of around $2 billion per mission to between $60 million and $90 million through the use of reusable rocket technology. 2. Sustainability as a cost driver. It might be expected that investments in sustainability would raise costs. However, the aerospace sector is finding that innovations in green technologies are not only essential for compliance with regulations but also for reducing operational costs in the long term. The shift towards sustainable aviation fuel SAF and hydrogen-powered aircraft is seen as a pathway to cost efficiency, contradicting the assumption that sustainable practices are always more expensive. 3. Labor shortage in a growing industry. Despite the booming demand for aircraft and defense systems, which is expected to grow significantly, there is an ongoing challenge with labor shortages. Typically, high demand would lead to increased hiring and skilled workforce growth. However, the industry struggles with attracting and retaining skilled labor, highlight a critical paradox. Companies are investing in automation and advanced technologies to counteract this shortage, which in itself could lead to a reduced need for human labor over time. For delayed production rates. Despite high demand, the aerospace and defense industries are experiencing strong demand, with forecasts indicating a need for nearly 44,000 new airplanes over the next few decades. However, the production rates are not meeting these demands due to supply chain challenges and labor issues. This situation contradicts the expectation that high demand would directly correlate with increased production output. 5. Regulatory pressure as a catalyst for innovation. While regulatory environments are often viewed as barriers to innovation due to compliance costs and red tape, they are now acting as catalysts for advancements in technology and operational efficiency. The requirement for emissions reductions has spurred investments in AI digital twins and sustainable materials which can enhance productivity and reduce costs in the long run. 6. Space tourism and accessibility. The rapid growth of the commercial space sector is creating a paradox where space travel, once seen as an exclusive venture for governments and wealthy individuals, is becoming more accessible to the general public. As companies like Virgin Galactic and Blue Origin work toward regular commercial flights, the notion that space travel will remain a luxury is being challenged. 7. Market size versus supply chain resilience. The global space economy is projected to grow from $630 billion in 2023 to $1.8 trillion by 2035. However, this growth is accompanied by vulnerabilities in the supply chain that could hinder progress. Companies are recognizing that while the market size is expanding, the resilience of their supply chains is critical for sustaining this growth, revealing a counterintuitive relationship between market opportunity and operational challenges. 8. Technological advancement versus labor skills. The expectation that technological advancements like AI and automation would eliminate jobs is being countered by the reality that these technologies often require a more skilled workforce to implement and maintain. Therefore, instead of reducing the necessity for skilled labor, the demand for highly skilled workers in tech-savvy roles is rising, complicating the labor market dynamics in aerospace. In conclusion, the anticipated reduction in space travel costs by 2027 is set against a backdrop of significant transformations and contradictions within the aerospace, telecommunications, and defense sectors. The interplay between cost reduction, sustainability, workforce challenges, and technological advancement is reshaping these industries in unexpected ways, suggesting that the future of aerospace will be driven by both innovation and the complexities of global competition. The projected 50% reduction in space travel costs by 2027 carries profound implications across various industries, particularly aerospace, telecommunications, and defense. While many reports outline the general benefits of this shift, certain key insights and nuances often receive less attention. Here are significant points that require focus. 1. Impact on global competition. The anticipated cost reduction in space travel is not merely a financial shift, it represents a fundamental change in global dynamics. As nations like China and India ramp up their investments in space technologies, the competition will intensify not just for space missions but for technological supremacy. This could lead to a new space race reminiscent of the Cold War era, where geopolitical tensions are exacerbated by advances in space capabilities. Significance. The implications of this competition extend beyond national pride. They involve national security, economic power, and technological leadership. Countries that can leverage reduced costs to enhance their space capabilities may gain significant strategic advantages, influencing global power structures. 2. The role of reusable technology. The success of reusable rocket technology pioneered by companies like SpaceX is central to the anticipated cost reductions. By decreasing the need for completely new rockets for each launch, this innovation fundamentally alters the economics of space travel. Yet the rapid evolution of this technology is often overlooked in discussions about cost. Significance. Understanding the intricacies of how reusable technology reduces costs can inform investment strategies and policy decisions. As more companies enter this space, the potential for innovation will also create opportunities for new market players and disrupt existing business models. 3. Sustainability and green technologies. While many reports mention the importance of sustainability in aviation, the specific advancements in green technologies often receive insufficient emphasis. Innovations in hydrogen-powered aircraft and sustainable aviation fuels (SAF) represent critical steps toward reducing the aviation industry's carbon footprint. Significance. The transition towards sustainable aviation is not just an environmental imperative, it also opens new markets and investment opportunities. Companies that lead in developing these technologies may secure a competitive edge as regulatory pressures for reduced emissions grow globally. 4. Supply chain vulnerabilities. The aerospace sector faces significant supply chain challenges, particularly regarding skilled labor shortages and material costs. Reports emphasize the demand for new aircraft but often underplay the ongoing issues that threaten to delay production and increase costs. Significance: acknowledging these vulnerabilities is crucial for stakeholders. Addressing labor shortages through educational initiatives and improving supply chain resilience will be essential for meeting the projected demand for approximately 44,000 new airplanes between 2024 and 2043. 5. Emergence of new markets. The growth of the global space economy from $630 billion in 2023 to a projected $1.8 trillion by 2035 illustrates the burgeoning opportunities beyond traditional aerospace sectors. As the demand for satellite technology and services increases, new players will emerge, particularly in telecommunications and data analytics. Significance: this economic growth has the potential to create jobs and spur technological advancements across multiple sectors. Companies should prepare to capitalize on these opportunities, aligning their strategies with the evolving market landscape. 6. The role of artificial intelligence. AI's integration into aerospace manufacturing and operations is another crucial area often glossed over. The technology is poised to optimize everything from flight operations to manufacturing processes, improving safety and efficiency. Significance: as AI continues to evolve, its impact on reducing operational costs and enhancing decision-making capabilities in real time could redefine industry standards. Companies that invest in AI now may lead the way in operational excellence and innovation. 7. Cybersecurity challenges. With the aerospace and defense sectors increasingly reliant on digital technologies, the associated cybersecurity risks are significant yet frequently underdiscussed. The shift towards more connected systems raises vulnerabilities that could be exploited by malicious actors. Significance: as the industry advances, prioritizing cybersecurity will be essential to protect sensitive data and ensure the safety of operations. Companies must proactively address these challenges to maintain trust and reliability in their systems. 8. Autonomous technologies in aviation. The potential for autonomous aircraft driven by advancements in AI and robotics is a transformative trend that warrants closer examination. The integration of autonomous systems could revolutionize air travel and logistics. Significance: the evolution toward autonomous flight presents both opportunities and regulatory challenges. It will require a shift in how aviation is regulated and perceived by the public, which may take time to evolve. 9. Investment in infrastructure. The aging infrastructure of aerospace facilities and the need for modernization are critical issues that often do not get the attention they deserve. As demand for air travel and space missions increases, so too will the need for updated technical facilities. Significance: investing in modern infrastructure is not just about meeting current demand, it's about future-proofing the industry. Companies that recognize this need can position themselves to lead in the next era of aerospace innovation. 10. Cultural shifts in workforce dynamics. As the aerospace industry evolves, so too will the workforce requirements. Companies must adapt to attract and retain talent in a highly competitive market, particularly as younger generations prioritize sustainability and innovation in their career choices. Significance: addressing workforce dynamics through training and development programs will be crucial to overcome the skilled labor shortages that threaten production capabilities. Companies must embrace this cultural shift to ensure long-term sustainability and growth. Conclusion: the projected reduction in space travel costs by 2027 offers a transformative opportunity for multiple industries. Yet critical insights often fly under the radar. By focusing on the significance of geopolitical competition, technological advancements, sustainability initiatives, supply chain vulnerabilities, and workforce dynamics, stakeholders can better navigate the evolving landscape of aerospace and related sectors. As the industry continues to innovate and grow, understanding these nuanced implications will be essential for success in the competitive global marketplace. 1. Reduction in space travel costs and its economic implications. The projected 50% reduction in space travel costs by 2027 is primarily attributed to advancements in reusable rocket technology and increased competition within the aerospace sector, particularly from private companies like SpaceX. This reduction is expected to significantly lower the cost of launching satellites and other payloads into space, driving growth in the global space economy, which could reach $1.8 trillion by 2035. As space travel becomes more economically feasible, it will lead to an expansion of commercial space ventures, increased satellite deployment, and enhanced connectivity through telecommunications. The economic implications extend beyond the aerospace sector. Industries such as telecommunications, defense, and logistics will benefit from lower costs and enhanced capabilities. This transformation will create new market opportunities, particularly in satellite services and space-related technologies, making space more accessible for both governmental and commercial entities. 2. Technological innovations and their role in aerospace. Technological advancements such as artificial intelligence, AI, machine learning, and additive manufacturing, 3D printing are central to the aerospace industry's evolution. These technologies are streamlining aircraft design and manufacturing processes, increasing production efficiency, and reducing material waste. For example, AI can optimize aircraft performance and fuel efficiency by analyzing vast datasets, while 3D printing allows for the production of complex components with reduced lead times. Additionally, the integration of lightweight materials like carbon fiber is critical for developing more fuel-efficient aircraft. The expected demand for nearly 44,000 new airplanes from 2024 to 2043 will necessitate these innovations to meet both production challenges and sustainability goals. As these technologies mature, they will not only redefine aerospace manufacturing but also influence associated sectors, paving the way for smarter, more efficient production systems. 3. Sustainability initiatives in aviation. Sustainability has become a cornerstone of the aerospace industry, driven by regulatory pressures and public demand for greener solutions. Innovations in sustainable aviation fuel, SAF, hydrogen-powered aircraft, and electric flight technologies are gaining traction as the industry aims to reduce its carbon footprint. Major companies are investing heavily in green technologies to comply with emerging regulations and to meet ambitious climate goals such as achieving net zero emissions by 2050. The shift towards sustainable practices is expected to reshape the market landscape, with companies that prioritize green technologies likely to gain a competitive advantage. Furthermore, as the demand for environmentally friendly air travel increases, the industry will need to adapt to changing consumer preferences, thereby reinforcing the importance of sustainability in future aircraft designs and operations. 4. Challenges in workforce and supply chain management. Despite the optimistic outlook for growth, the aerospace industry is grappling with significant workforce and supply chain challenges. A shortage of skilled labor is a persistent issue, exacerbated by the rapid technological advancements requiring new skill sets. Additionally, ongoing supply chain disruptions influenced by geopolitical tensions and raw material shortages hinder production rates and complicate logistics. The industry's reliance on a limited number of suppliers increases vulnerability to disruptions. Addressing these challenges requires strategic investments in workforce development, including upskilling and apprenticeship programs, as well as diversifying supply chains to enhance resilience. As companies navigate these complexities, the focus on building a robust and adaptable workforce will be critical to sustaining growth in the aerospace sector. 1. The Apollo Program, 1961 to 1972. The Apollo program was a series of space missions conducted by NASA aimed at landing humans on the Moon and safely returning them to Earth. The program began with the goal set by President John F. Kennedy to achieve this feat before the end of the 1960s. Apollo 11, the most famous mission, landed astronauts Neil Armstrong and Buzz Aldrin on the lunar surface on July 20, 1969. The program not only demonstrated the feasibility of human space travel but also spurred technological advancements in materials, telecommunications, and computer science, significantly impacting multiple industries. 2. The Wright brothers and powered Flight 1903. The Wright brothers Orville and Wilbur Wright invented and developed the first successful powered aircraft, achieving the first controlled sustained flight of a powered heavier-than-air aircraft on December 17, 1903. Their innovations in aerodynamics, control systems, and propulsion technology laid the groundwork for modern aviation. This milestone not only transformed transportation but also influenced the development of military applications and global trade, marking the beginning of the aerospace industry as we know it today. 3. The Space Shuttle Program 1981 to 2011. NASA's Space Shuttle program was a revolutionary initiative that enabled reusable spacecraft to transport astronauts and cargo to and from low Earth orbit. The first shuttle flight, STS-1, launched on April 12, 1981. Over its operational life, the program facilitated numerous scientific missions, including the deployment of satellites, construction of the International Space Station (ISS), and Hubble Space Telescope servicing missions. The shuttle's reusability significantly reduced the cost of access to space and paved the way for future commercial space endeavors, influencing the aerospace and telecommunications industries. The aerospace, telecommunications, and defense industries are on the verge of transformative changes. Primarily driven by an expected 50% reduction in space travel costs by 2027. This shift is anticipated due to advancements in technology, increased investments in space exploration, and heightened global competition, particularly from countries like China and India. Key trends and predictions. 1. Cost reduction in space travel. The advent of reusable rocket technology, exemplified by SpaceX's innovations, has already led to substantial reductions in mission costs, from NASA's historical average of $2 billion per mission to between $60 million and $90 million for commercial missions. This trend is expected to continue, making space more accessible and fostering greater participation from both public and private sectors. 2. Growth of the global space economy. The global space economy is projected to expand from $630 billion in 2023 to approximately $1.8 trillion by 2035. The growth will be fueled by advancements in satellite technology, commercial space travel, and the increasing demand for satellite-based services. This economic expansion will create new opportunities across various sectors, including telecommunications, where satellite connectivity will become more widespread. 3. Technological advancements. Significant advancements in artificial intelligence, AI, machine learning, and additive manufacturing, 3D printing, are set to revolutionize aircraft design and manufacturing processes. The use of lightweight materials such as carbon fiber will enhance fuel efficiency, especially in the development of electric and hybrid aircraft. By 2025, the demand for new aircraft is expected to soar, with forecasts indicating the need for approximately 44,000 new airplanes by 2043. 4. Sustainability initiatives. The aerospace sector is increasingly prioritizing sustainability. Innovations in green technologies such as hydrogen-powered aircraft and sustainable aviation fuel (SAF) will be essential for reducing the industry's carbon footprint. Companies will likely invest heavily in these technologies to comply with regulatory standards and meet public demand for environmentally friendly options. 5. Workforce and supply chain challenges. Despite the positive outlook, the aerospace industry faces ongoing challenges related to workforce shortages and supply chain vulnerabilities. The need for skilled labor remains critical, and geopolitical tensions are impacting material costs. Companies will need to implement strategies to attract and retain talent while simultaneously diversifying their supply chains to mitigate risks. 6. Emerging markets. The Asia-Pacific region is expected to lead the demand for commercial aircraft driving innovation and production capabilities. This region's growing middle class and increasing air travel demand will significantly impact the global aerospace market, creating a competitive landscape for manufacturers and service providers. 7. Defense sector growth. Heightened global security concerns are likely to result in increased defense spending. The demand for military systems and advanced aerospace technologies will continue to rise, further bolstered by geopolitical tensions. As countries prioritize national security, the defense sector will become a vital area of investment. 8. Space tourism and commercialization. The commercialization of space travel is set to take off, with companies like Virgin Galactic and Blue Origin leading the charge. As costs decline and technology improves, space tourism will become more mainstream, opening new avenues for economic growth and exploration. 9. Autonomous aviation. The integration of AI and robotics in aviation will pave the way for autonomous aircraft and air taxis. These innovations will enhance efficiency and safety, transforming urban air mobility and revolutionizing how we approach transportation. Timeline of events. 2023, the global space economy is valued at $630 billion. 2025, global passenger traffic is projected to exceed 10 billion, and the commercial aviation sector may generate $1 trillion in revenue. 2027, a significant reduction in space travel costs is expected, driven by technological advancements and increased competition. 2035, the global space economy is projected to reach $1.8 trillion. Conclusion. The aerospace, telecommunications, and defense industries are poised for a significant transformation by 2027, marked by a dramatic reduction in space travel costs and rapid advancements in technology. As these changes unfold, the sectors will benefit from increased investments, innovative solutions, and a focus on sustainability. However, challenges related to workforce shortages and supply chain vulnerabilities will require proactive strategies to ensure long-term success. The next decade promises exciting opportunities for growth, collaboration, and exploration as these industries evolve.